Hi everyone. Today is my honor to give you a quick introduction to the Digital Humanities for the seminar on deep learning and Digital Humanities at TU Darmstadt this winter semester. My name is Thomas Heider and I'm giving the seminar jointly with Steffen Eger. So I structured this talk the following way. So first I'm going to show you the syllabus, meaning I'll show you the topics that you can write your term papers about. Then I'll give you some examples of visualizations with distant and close reading to be followed by some problems and applications in digital humanities, essentially seeing how to formulate research questions. And in the end, I hope to give you some overview of what digital humanities means as being a scientific field and all the different fields that are involved and the plurality of methods. I'll finish off with a short history of digital humanities, give you a little bit of further literature, and tell you who I am. So check out the reading list on Steffen Eger's GitHub to get the reading material, to get an overview of all the different topics and different papers that you can do your talk about, write your term paper about. And if you have any questions, shoot me an email or best send Steffen Eger and me an email both so we can respond accordingly. Little disclaimer, so this seminar tries not to give a comprehensive introduction to either digital humanities or deep learning. So we do not attempt to cover all topics that are possible in either field, but instead we attempted to give a selection of topics and applications that are tangential to digital humanities that occur in the digital humanities field, and we will be approaching these DH problems with deep learning methods. And we focus mostly on literature from the natural language processing community. So, but if you're interested more in DH or deep learning itself, check out maybe the Lit Lab at TU Darmstadt or Steffen Eger's course on deep learning for NLP. So essentially, we give you a range of topics, and whatever topic is not as selected, we might drop then. But we're starting off with this talk, like I'm introducing to the digital humanities. Steffen Eger will introduce you to deep learning, and then you can select from a range of topics, including corpora and annotation, that is which data sets are used, how these data sets are annotated, then optical character recognition and spelling normalization, but also emotions, metaphors, semantic change, also stylometry and variation, over to literature with fiction and narration, but also poetry, music, and the arts. And in the end, we have some meta topics that are also interesting to the humanities community, which are ethics and bias, explainability and interpretability of deep learning architectures and models, and also a bit of a meta-analysis of scientific literature. So to go through the topics one by one, first of all, it's quite important to have data that you can analyze. But the big question is, how do you obtain such labeled data, especially for humanities applications? Do you use expert annotators or can you use crowdsourcing? And in the end, how do you ensure or measure that your annotations are consistent? And how can you deal with competing annotations? On the right there is an example of a named entity annotation that you, for example, can nest So you have Isabella as a person, you have Isabella's husband as a person, and you have the elder brother of Isabella's husband is also a person. Right. So, and at each section, I will give you a bit of an indicator of how important this specific topic is for deep learning and for DH and corpora annotation are not very central to deep learning. Of course, you need data, but deep learning itself is typically operates on data sets instead of creating them. But data is, of course, and how you create the data and how you operationalize your annotation scheme is, of course, very important for digital humanities. Spelling normalization and optical character recognition asks the question, how do you unify historical spelling variants, for example, das versus das? How do you do state-of-the-art optical character recognition, and is it good enough already? And if it's not good enough, how do you carry out post-correction? Emotions deal with how to detect emotions, for example, which literary character feels what emotions, or whatever the emotional arc in a story is. And a big question is also, how do you model discrete emotion labels, or how do you deal with continuous labels? The examples I've shown here, so you have emojis, for example, that would be somewhat discrete, but you also have Plutchik's wheels of emotions here in the center with, for example, joy, trust, fear, surprise, sadness, disgust, anger, and anticipation are basic emotions. But you might also have continuous labels like valence or arousal that range from on a scale from 1 to 5, for example, and that express a bit of a different thing, but could be also maybe mapped to discrete labels. Metaphors are quite important to language to speech, to also to literary speech, to literary language. And well, how do you identify metaphors in text, and how do you distinguish them from literal text is among the topics. And for metaphors, of course, it's very important. How do you figure out which features actually get transferred from a source concept to a target concept? For example, in the simile, my cat is as fierce as a tiger. The fierceness of the tigers get transferred to the cat. Other metaphors include the voice of love, that the features of love get transported on a voice, or conceptual metaphors like love is a journey or more is up. Semantic change deals with the question, how do we measure meaning change over time? So diachronic over time, synchronic would be within a certain time frame. How do you then quantify spatial meaning variation, since semantic meaning is typically represented with vector space models of words, and these words then move through the vector space. So that's a big question, how do you represent that? And a very current question is, how do you measure actual change and not some other effects, for example, like frequency of a term? Stylometry and variation deals, for example, to identify the style of an author, or how do you transfer the style of one author to the other one, or across genre or gender or whatever. And also, how do we measure other extra-linguistic variables like regional variation or gender or writing quality? And well, for digital humanities, there was always a central question, is the authenticity of certain texts. This has been questioned for certain texts that were attributed to Shakespeare, and there is an active research stream trying to figure out which text was actually written by a certain author and which one was not. For fiction and narration, the question is, well, how do you identify mentions of certain characters? How do you qualify the relations among characters in a novel? How do they stand to each other? Also over the course of the novel, for example. So how do you then extract event script knowledge so you can model narration or the plot, as you can see on the right graph here. So where you have a criminal in blue that gets arrested by the police, is then charged by the police. The criminal pleads guilty or innocent, and in the end, a judge or a jury convicts the criminal and sentences the criminal. And well, you can not only analyze fiction, but you can also generate fiction, and this is also active right now with deep learning methods. For poetry, music, and the arts, central question for natural language processing people has been how to generate poetry and what features poetry then has. For example, usually it's operationalized with rhyme or rhythm and meter. But the question is that still poetry, and how do you evaluate whatever the model generated? And well, what distinguishes poetry, good poetry from bad poetry? What distinguishes it from prose and other texts? And well, how can we evaluate generated art or music? What kind of criteria do we need to employ to have a good sense of generative art? To get to the meta topics, well, ethics and bias is quite important to figure out which gender, which race, which age a certain data set is biased towards, and if and how these biases get amplified by certain models, and well, how can we then mitigate this either by changing the data distribution or telling the model what to correct. Explainability and interpretability is fairly important to digital humanities research, as the humanists, of course, would like to know whatever hypothesis is supported by a certain model and what is not, and figuring out why and how a model reached a certain conclusion and which features describe certain problems. So essentially, how can we interpret neural models and explain the results? And well, can we learn complex functions of data, but still understand the models? And I only gave this 2 points for DH here because of course, it's important for the field itself, but most literature on the problem does not deal explicitly with humanities questions themselves, but it might be quite interesting further down the line. And in the end, well, the analysis of scientific literature itself can be quite important to figure out what kind of methodology is used, and if certain claims are supported by whatever method you're using. Can you verify or falsify certain scientific claims? And also, of course, how are rhetorics and citations used in certain papers, and how can you investigate this in a quantitative way? Right. So to get a feel for what the digital humanities are doing, I'd like to give you some examples with the visualization of close and distant reading approaches. So to make the distinction, close reading is a close examination of a particular text or an artifact, and distant reading tries to find larger patterns in larger text collections. So close reading looks at a single text, and distant reading looks at a lot of texts at once. So close reading, well, as said, is a close examination of a particular text. It's very detail-oriented, and typically you have a multi-layer annotation where you also read between the lines, trying to figure out what the meaning of this particular text in front of you is. And then this allows you to immediately relate different features, for example. with different features with each other. So, for example, if a poet uses a rhyme, you can investigate what this means for the meaning of the poem, for example. And computation can also be used in close reading analysis. For example, you can do a keyword search and then close examine certain passages. If you want to know what the meaning of God is in Moby Dick, you do a keyword search for the word God and then examine all these passages where it disappears in. And well, of course, computation can also very much help you to visualize or augment a text to get a better understanding of it. So typically without computation looks like this, that you would scribble on the page and between the lines, but the digital tools can also aid this, that you can make margin notes or highlight certain things, and as for it, computational tools have been useful for literary scholars already. For poetry, this could look something like this, where you have sound recurrences. For example, Humpty Dumpty is a rhyme, and the system can show you that these two words sound very similar, or other features like assonance and vowels get repeated, or in the second example, where certain surface forms get repeated. So that allows you to get a feeling of the sound structure of these poems. Distant reading, on the other hand, looks at many texts at once and trying to find larger structures. And Franco Moretti claimed that this mainly boils down to making maps, trees, and graphs. Here added text and networks. So this is what people tend to look at. And a visualization of this can look like this, like look at the text reuse or plagiarism in the Bible, and you can visualize whatever passages get reused and who plagiarizes from whom. But you can also make geological maps. For example, if you have some geographic information, or you can construct social networks. In the middle, for example, Thomas Jefferson's social relationships, or on the right, to visualize the last generations in the Bible. Right. To get to some problems and applications, I will show you some fictive examples of problems in digital humanities, and also try to illustrate whatever computational tools can be used for that. And well, you can categorize some digital humanities problems like this, that a main focus of much digital humanities research still is to create digital or critical editions, like the Perseus project, where you create a corpus, you have some annotation workflows, you have some annotation tools that happen on a computer, and you deal with markup languages and archiving solutions to make humanities research sustainable. Digital humanities research also has a huge focus on visualization and data design, as mentioned, like the distant and close reading approaches. You can make trees, maps, graphs, and visualize literary data, historical data, or even do virtual archaeology if you, for example, interested in dating vases from the Greek period and so on. And lastly, quite interesting is cultural analytics and data mining, which is under the new term cultural nomics, which includes, for example, social network analysis, or the evolution of concepts, or the evolution of society, but also authorship verification and so on. So the first example is from philology, which deals with literature, but you can also subsume encyclopedic knowledge under this. So one question that could arise if you look at text data, or if you look at a novel, for example, to figure out who spoke with whom about what, and who likes whom. For example, the love interest of the main character likes him or doesn't like him, and that determines the end of the novel. And then it could be quite interesting to use a distant reading approach to figure out which emotions are felt by the characters towards each other. On the right bottom here, I included a graph that is from my own research. We created a network of musicologists that we extracted from an encyclopedia, and we did this via named entity recognition and building the graphs from the co-occurrence information of these names. So if these names are mentioned with each other or in each other's biographies, then they get related, and in the end we build the graph. But you could be also interested in what relation they are specifically to each other, which isn't encoded here. Then you could use a dependency parser, or if you want to figure out which character is meant by a certain pronoun, then you need a coreference resolution. If you want to find out who does what to whom, you need semantic role labeling. If you want to analyze emotions, you need to do sentiment or emotion analysis. In archaeology, you are typically dealing with a bit more physical objects, for example, cuneiform tablets. So writing from 4,000 years ago. And to figure out what was written on cuneiform tablets, you can do a 3D image analysis and essentially optical character recognition with 3D methods. And well, then you could have the possibility of translating whatever this extraction brought into modern languages. And there is actually active research at the University of Heidelberg and also in Berkeley. So to wrap these problems up, another examples include, for example, music information retrieval, such as implementing recommendation systems for new music, which is what Spotify is doing. DJs are quite interesting in estimating the key and the tempo of the tracks automatically. And also musicological research has quite the laborious task of converting sheet music to editable scores for MIDI, and automating this would greatly advance the archiving of certain scores. Also, if you are interested in the history of philosophy, then you could look at the evolution of philosophical terms, for example, through a semantic change analysis in a philosophy corpus. So how can this seminar then help you with your future research? Well, I hope you will learn how to formalize or operationalize a certain humanities problem. So if you are collaborating with a humanist, for example, try to figure out what your data looks like. And well, if you want to have a certain annotation, you want to do a certain analysis, then would be interesting to see if you need human annotators, if you need to train these human annotators, well, if you can use crowds, if the crowds can actually replicate what the experts do, then which machinery then helps you answer the research question of the humanist, for example, and then in the end, well, how interpretable are the results of your modeling? Right. So now we have seen a whole lot of examples. Let me get a bit more abstract and show you a bit about the digital humanities as a field. And in simplest terms, you can use the working definition that digital humanities is born of the encounter between traditional humanities and computational methods, that is approaching humanities problems with computational methods. It can be a bit more complicated than that, and not everybody might agree with you here, but this is the most simplest definition. A big problem between the fields of the humanities and the exact sciences is that humanities tends to employ a method of criticism, that philologists are interested in the aesthetic value of a text, for example, and its cultural and historical relevance of an artifact. And philologists might also deliberately search for ambiguity to figure out all the multiple meanings of a certain text. While the exact sciences or the quantitative approaches tend to look for a ground truth and consistent data and reproducible results, which is quite at odds with trying to incorporate all kinds of ambiguous messages. So is digital humanities then the best of both worlds? Well, yes and no. So interdisciplinary research has certainly recognized that there is an apparent gap between the disciplines. And moved to amend this, for example, through more rigorous formalization of digital humanities problems, or resorting to modeling simpler concepts and focusing more on the computer science side. So looking at it as a Venn diagram, you can draw a circle for the humanities, you can draw a circle for the computer sciences, and then call one intersection digital humanities, and where we are moving currently are the computational humanities, more or less. And this is where most of our literature will come from, is from computational approaches to the humanities problems. And ideally, well, you would have a sweet spot for a collaboration that your problem is challenging both for the humanities and for the computer sciences. But of course, you can also disadvantage one or the other fields, but might still be worthwhile investigating. So essentially, the big question is when you formulate your research question and trying to figure out what to do, is you can focus on answering humanities questions. Then you would model a humanities problem and try to get interpretable results. But often you will have to accept slow development cycles and small data sets. On the other hand, trying to advance computer sciences, then you can model a humanities data set, but often you have to accept that humanities problems are operationalized in a fairly simple way. But you could still model hard problems and or go large scale and analyze huge data sets, even though your operationalization might lose a bit of granularity to answer certain humanities questions. So, and the focus of the seminar, as I mentioned before, is we will discuss technical research, trying to get insight to humanities problems by structuring the seminar around humanities problems. And we will mainly approach this from a natural language processing perspective, and that is computational humanities. And also, then we will look at deep learning approaches applied to these certain problems that can arise in the humanities. And participating fields, well, then text mining, computational linguistic, and natural language processing, where text mining mainly means to transform an unstructured text into structured information, into structured data sets with, for example, information retrieval or extraction, such as named entity recognition, topic models, search engines, and so on. And the difference between computational linguistics and natural language processing is mainly that computational linguistics traditionally has a strong grounding in linguistic theory, while the natural language processing community tries to process language by any means, and especially with the advent of deep learning, linguistic theory has often been abandoned in end-to-end models. Right. To get to the end of this talk, I'd like to give you a short history of digital humanities and hand you some further literature. Well, the age started essentially already 120 years ago, where Sherman or Mendenhall took some text and manually counted the length of sentences, the length of words, and how that relates to certain authors, or German tried to do a history of style, how certain sentence length changed over time. Digital Humanities proper is often said to originate with Roberto Busa's work on indexing Thomas Aquinas' work. So essentially making a book indice or a register with the help of IBM to create concordances and frequency lists of the terms in Thomas Aquinas' books. The Pesos project gives you a digital or a critical edition of Greek writers, and that was already established in 1987, and also the text encoding initiative to try to standardize XML and SGML standards also started in the 80s. You can break it then down to 4 epochs. The first one being style counting, that people would just like count the length of sentences. Then to humanities computing, to digital humanities proper with 1989 be having the first international conference. And since the advent of deep learning, and what we are trying to do, it would be a deep digital humanities. And these are some further reading materials that might be worth looking at, even though they approach the problem mainly from a humanities side, as digital humanities typically refers to humanists that use digital methods and not the other way around. There are some YouTube videos that give you further information, or the Duke Library made an effort to collect some definitions and give a short history of the field. So to tell you who I am, finally, so my name is Thomas Heider. I was born in Landshut in southern Germany. I got my bachelor's and my master's in computational linguistics and philosophy, and studied in Heidelberg, Groningen, spent a little bit of time in Michigan, and I also have a bit of background in the fine arts and poetry. So if you have any questions about that, just shoot me an email. Currently, I'm a research fellow at the Max Planck Institute for Empirical Aesthetics in Frankfurt with Winfried Menninghaus, and I'm a PhD candidate at the Institute for Natural Language Processing at the University of Stuttgart. And my time there is coming to an end as I'm trying to wrap up my thesis. So essentially, my main research interests revolve around corpus-driven machine learning to understand the features of literature, the analysis of style and tone, that is how people communicate in different situations, and also the evaluation of art and creative language in terms of which emotions does it evoke, or what the poet is trying to do. And my thesis then boils down to mainly 3 parts. The first one is modeling poetic style to figure out what poetry actually is, which style appears in this genre that doesn't appear in others, what does it do with people. And then diachronic analysis to find out how poetry evolved over time, and also emotions and aesthetic evaluations. Which emotions do you feel if you like something? Which emotions do you feel if you don't like something? To sum this all up, so digital humanities are a collaborative effort, typically seen by computer scientists and humanists. And the history of the age already reaches back over 100 years. And now more than ever, you have new opportunities to find new research questions and possibly rewrite history with the new tools and methods that we have. And I encourage you to look at the distant readings methods, especially from a deep learning perspective, to benefit digital humanities. All right. See you on the next Zoom call, and goodbye.